Okay, so I'm doing a question in the homework. This is 6.8 with feedback, and I'm doing this in as a student request. So let's start from the beginning. The addition of hydroiodic acid to silver nitrate solution precipitates silver iodide. Precipitates silver iodide according to the reaction blank. All right. When 50 mils of silver nitrate is combined with 50 mils of blank in a coffee cup calorimeter, the temperature changes from this to this. All right, so first thing I see with the coffee cup calorimeter, first thing I think of is Q is equal to MC delta T. All right, so we get this reaction going on inside a coffee cup calorimeter. And the reaction itself is the system, right? And we know that the Q of the system is equal to the minus Q of the surroundings, and the surroundings is what's catching the heat. That is the water. That's what's catching all the heat of the reaction coming out, right? So I'm going to calculate Q of the surroundings. Then I'll take the negative of it, and that'll be the heat that the reaction lets off. And then we'll figure out where to go from there. All right, so Q of the surroundings is going to be, that's the water, so it's going to be the mass of the water times the specific heat capacity of the water times the delta T of the water, okay? So delta T, we can see, is right here. Delta T is equal to 0.51 degrees Celsius. 0.51 degrees Celsius. Okay? Specific heat of the water is 4.18 joules per gram degree centigrade. And the mass of the water. When we get the mass from the volume of the water is 50 mils plus 50 mils. 50 mils plus 50 mils. So it's 100 mils, right? And the density is 1 gram per mil. So the mass is going to be 100 grams. All right, that's a little bit, I'm doing that in my head right now because it's a 1-to-1 ratio, 1 gram per mil. But let me say, if that doesn't make sense, you should ask about that. If it's 100 mils, why is it 100 grams? The answer is because it's water, and it's 1-to-1. That's something that you might want to you certainly want to make sure you understand. Okay, so I'm doing delta T, C, and mass because I'm used to it, right? This is an old habit of mine. I know it's MC delta T. You've heard me say that in class. So now we know Q of the surroundings. Q of the surroundings is equal to 100. I'm going to leave the units out. Well, no, let's leave those in, I'm afraid. If we 4.18 joules per gram degree centigrade and 0.51 degrees centigrade. Okay, so let's come over here. Grams cross off, degrees centigrades cross off, and we're left with joules. Let's go back to color black. Can't do that in my head. I'm going to come over to a different part of my calculator. 100 times 4.18 times 0.51, 213.18. Okay, 213.18 joules. That's how many joules were put into the water. Now, that's how many joules were put into the water. Now, if that's how many joules were put into the water, we know the Q of the surroundings is equal to minus Q of the system. And so the Q of the system is equal to minus 213.18 joules. Right, but that's just the joules for the number for this reaction that we have here. We want to know the number of joules per mole of that reaction. So in order to calculate that, let's go to a different color here. And let's set this up as a table. We've got 50 mils, that's my volume, and let's do it in liters. 0.05 liters. And what is the volume of my hydroiodic acid? That appears to be also 0.05 liters. 0.05 liters. Okay, what's the concentration of my hydroiodic acid? The concentration, that's moles per liter. It looks to also be 0.05. Right? It looks to also be 0.05. Okay, I've just got a lot of children running around here, and I'm gonna take a second and ask them all to be quiet. In fact, I'm gonna ask you guys to go into another room so you don't have to be so quiet. And we know that N is equal to C times V. That's why we did that, right? So the number of moles of the reaction is going to be 0.05 times 0.05, which is going to be, oh, I can't do that in my head. What is 0.05 times 0.05? Okay, looks like it's 0.0025, which is equal to 2.5 times 10 to the minus 3. Okay, that's how many moles of reaction we have going on. Well, by the way, this is very convenient because it's a 1 to 1 to 1 to 1 ratio, right? So if I've got 2.5 times 10 to the negative 3 moles of silver nitrate, then I've got a 2.05 times 10 to the 2.5 times 10 to the negative 3 moles of reaction, right? So it looks like I've got 213.18 joules. It's rather negative because it's the system. It's the system now divided by 2.5 times 10 to the minus 3 moles. Just a minute. I need to tell my children to stop rattling papers. Children, can you stop rattling papers and go in the other room? It's going to be magnified with the microphone. Thank you. Okay, so we divide this out, and we find that this is 213.18 divided by 2.5 times 10 to the minus 3, 85272. Let's go back here. 85272 joules per mole, which is equal to 2 sig figs. I think the question was, write this out to 2 sig figs. 85 kilojoules per mole. And when we write this in the computer, we're simply, because we're the delta H of the reaction, right? That's per 1 mole of reaction. So we're simply going to write it's minus 85 kilojoules, and that's going to be our answer. Okay, hope that's helpful.